All right. Hello, everyone. Thanks for joining. I am Paul Balog. I'm a developer advocate with Grafana Labs. So, got all my contact info there on that QR code. So, if you do happen to scan that, you can get all the pertinent details where you can spam me and all the other stuff. But anyway, but yeah. So this is actually a talk that I've given before. It's been a while, but I have given it before, but this will be the first time that it's actually recorded. My past time we had video issues at the location, and then so wasn't working. They were using MS Teams to stream it, but that didn't work out so well. And then before that, we just didn't have any live streaming capacity there. Where was that? Oh, that was at Disneyland. I presented this at Disneyland. Yeah, there was a conference there for testing Unity, and then so I presented this there. So that was fun. Lots of people running around with mouse ears. But anyway, so embracing disruption. So why are we here? Get to the straight point here. So obviously applications, as everyone knows, is reliability is hard. Complex architecture, things are getting more and more complex. With Kubernetes, there's lots of moving parts, many points of failure, potential points of failure. And then, the tooling is not the perfect thing yet. Someday we'll get there, but some of the practices are still evolving. So, of course, everybody wants your system to be reliable. So you got high demands, you got pressure from your management, all that. Your service level objectives are going to be high. People are watching those. You need to have your systems up. User experience. People are getting pretty particular. They're, folks are getting upset if their, page load time is, a second. It's got to be sub-second. And as we keep adding things and more users and all that, we typically get this hockey stick, activity sometimes where under load, we'll start seeing some problems and delays. And things, of course, are getting more distributed. So this is an actual image of some services from Netflix way back. And this is probably a 10-year-old image, honestly. I'm sure they have many, many, many more services than that nowadays. But just to show that there's so much stuff going on, so many moving pieces. And unfortunately, despite all of our best intentions, some of this interdependency can create a very small little weakness that's going to have the whole thing come crashing down. So, that wasn't just me. That's everyone, right? You are not alone. All right. So in order to learn, it's always best to go back and see where we came from. So, back in the old days, we did our little quarterly or, twice a year releases. You just did the testing right before the release, right? QA was always the bad guy. It's like, what? We worked months on this. And now you're saying that we can't do this. This is not working right. You're messing up our release schedule. And then we did this stuff manually rather. It was these QA folks were usually click, 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 click. A lot of times it wasn't all that good automation. They were the bottleneck. We couldn't really get all the coverage that we really needed. And then, test and production. 2 environments. Now with DevOps, we're doing things like, you can do weekly, daily, or as needed, really, is the release frequency. I mean, I in my past life, I always was pushing that I want to be able to deploy immediately, always, constantly, have it go through the automation, test, go run all the time. You feel safe, hitting release or deploy, and then let's go have a beer at lunch. Maybe 2. I don't know. It depends. But But yeah, so you would frequently test. If you would have big features, you would always be running them nightly to make sure that everything's kosher. Do synthetic monitoring. Trying to think of the company that used to do that. Pingdom, I think, was an early synthetic monitoring where it's sitting there just kind of setting a tracer essentially through your system to just make sure that everything's up and running. Things are automated in their CI/CD pipelines. Got your staging environments that might be long-lived, and then nowadays you get the ephemeral environments where you could sit there and use Terraform or OpenTofu, rather, let's say that, to spin up an environment just to run some tests and then tear it down. So the fun continuous cycle here. So, we always did our unit testing, our integration tests, contract tests to verify APIs are not breaking. The functional testing just to make sure that everything's working properly. The end-to-end to make sure that what a front-end user is going to see is correct. And then load testing. And of course, you're going to have your applications are going to be instrumented. Or if you're using eBPF nowadays, maybe automatically instrumented. You'll have your observability platform like, Datadog, Grafana, New Relic, Honeycomb, all those. So it's kind of a must-have. But as we increase the scope of our tests, starting simple, and then you start testing more frequently, continually expanding and evolve over time. So you get the snowball as things are becoming more and more reliable as you keep adding to your toolbox of tests. But really, we always learn from failure. That's the best teacher, right? So that's where we can start using fault injection. So of course, the little definition here that it's a software technique introducing errors to the system to ensure that we withstand and recover from those issues. And of course, typically we see those being in production, right? So that's where we're going to see, oh yeah, this issue bit us before in the past. Well, we want to take those issues and then we want to learn from them by bringing that scenario back into the development pipeline so that we can ensure and test and make sure that we are resilient to that scenario, whether it's a service going down or, complete loss of network, something simple like that. Oh, there. Sorry, I had the delayed animation. It gets me every time. I needed to click that again and have the little flame there because that makes it look cool. But yeah, so we want to build in more confidence into our system. So we bring, as I said, those incidents, we'll bring those back into the development. And then we can kind of apply that as being chaos testing. So we're going to actually, inject the faults. Now, one of the original, I guess, big names here, these two folks, much smarter than I am, but they were at Netflix, and then they started doing introducing the whole chaos engineering concept, bringing in these availability experiments. But they did find that most of the issues can be brought down to latency and the response type for recreating these scenarios. All right, so now this is where we have the nice little K6 ad. Now, but yeah, so, and I just had to update this. So this is fresh as of today, the roughly 22.4 GitHub stars is, like I said, earlier today. We do shift left. We promote the shift left testing. We're primarily known for a load testing tool, but we're actually kind of a bit more than that. We do, we're pretty flexible. And one of those things that includes or that enables that flexibility is we have an extensions framework so that you can create custom Go modules that you'll compile into K6 And then that way, then you can run custom functionality. So we have some things that, basically will incorporate the kubectl command line. So you can sit there from a JavaScript source. These are all written in, I think I have it listed there as JavaScript. Maybe that's another slide. But your test scripts are actually written in JavaScript. So using like XK6 Kubernetes, you can actually use kubectl commands directly into your JavaScript test. If you needed to do something like, create a namespace or update a config map or something like that. And then with K6, yeah, so here, open source, fully open source. It's, with Grafana, that's our thing. We're very much into the OSS ecosystem. It's scriptable so that you can include it into your CI/CD pipelines. It's written in Go, so of course it's performant. And one of the things I always say is I try to say, when I say go, you say performant. Go, performant. Go, performant. Okay. And then, as I mentioned before, it's extensible so that we have these extension points where you can do that. You can also adjust outputs and things like that. So, and again, it's not meant to be a big advertisement, but anyway. So, testing with errors. Okay, and this is where I rely on somebody else gave me these numbers, and it wasn't ChatGPT for the record. So it may not be a hallucination. It's probably real. I'm going to trust that this person that had the numbers and did their research and really knew it. But 92% of the catastrophic system failures are due to handling of non-fatal errors. So just not handling them appropriately, back in the Java days, having the throws, but maybe just, catch exception and just keep going. Let it fail. But yeah, and then 58% of those could have been just discovered through simple testing of the error handling code. Okay, so yeah, so see, this is where I even kind of glaze over talking about these things with the numbers. So yeah, the 35% of the errors are due to being like overreactive. So it's like, back in the Java days, the system exit 0. Basically you're going to shut down the JVM if you get any kind of error. And then it's like, oh yeah, very bad. So don't do that. Low context, so not enough logging information or not enough to give you any kind of idea of what really happened. Just relying on a stack trace is not always enough. And then, of course, the incomplete, the infamous to do, handle this error to do. All right, and then so. Now, to address this type of thing, this is where we want to bring in the chaos testing so that we can kind of catch those types of scenarios early, and then really emphasizing, verification over experimentation. So like chaos experiments are kind of like chaos engineering is typically you're trying this stuff against production. That's kind of like where it lives. You're going to start doing those experiments. So this, with chaos testing, it's intended to be upfront. So you're trying to verify that your system is handling issues correctly. And then again, yeah, focusing on uncovering unknown faults to ensure proper handling of the known faults. All right. So here's just a nice little diagram just to show that, again, we're learning from the production system. We're going to learn from real incidents. We're going to incident enacting and chaos experiments, kind of synonymous, really, I guess, or the same thing there. Those are going to be happening in production, but we want to take those results, those scenarios, and bring them back into our development area so we can use them in chaos testing. For tenants, Adopt incrementally. Don't just go all in all at once. You're too many variables, right? Isolation. Just do it step by step. Keep it to a specific application. Don't just go, trying to, again, too many variables. Don't go doing multiple systems at the same time. You want to do these things in isolation so you can fix each one independently, kind of whack-a-mole. You want one mole coming up, not three at the same time. Chaos is code. Do your best practices of like creating shareable libraries, things like that. And then again, controlled chaos. Just don't go doing everything just because you can, just to see what happens. Don't cut the cable to the data center. Do it in a controlled manner. You don't want to break things. You just want to make sure that things are reliably continuing. Yeah, that sounds horrible. But anyway, chaos testing in action. All right. So now this kind of gives a setup for the demo that we'll have. Now, I don't know, is everybody familiar with OpenTelemetry? Probably, maybe, hopefully. But anyway, OpenTelemetry project has a killer demonstration app, which is like, it's a polyglot, it's multiple languages, multiple services. This is the setup here. It's using even asynchronous messaging with Kafka. It's actually really cool, and it's a very realistic demonstration. So it's like, it's not your little hello world test thing. This is like a real live type of setup, but it's a store front, astronomy shop. So shopping carts and all that good stuff. So this is what we're going to use with the demonstration. So it's a full microservices setup. And then what we can do is we could then, start injecting some failures on back-end services. And then that way, then we could use testing on the front end to see how those are affected by, per se, we're going to do the recommendation service. So we're going to go and see how we can affect that. Okay. So that's just kind of the setup for the demonstration, which we'll have now. Okay. And this is the one, oh man, since I had the commute to come in, I always come in like at, 10 a.m. and then I hang out, have some lunch with folks I used to work with. And, and then I'm frantically working at Starbucks trying to update slides and all that for this. And then I started going through the demo. I had been messing with some local clusters and that for Kubernetes. And then it's like, I about had a heart attack. I was like, oh, it's not working. And it's like, what is going on? So I'm like, it's the slow network. It's like, oh man, hopefully I'll get here on the faster Wi-Fi and then everything resolves itself. And luckily it did, I think. So we'll see. So we'll see if the demo gods are good to me. I think they will be, but anyway, but I have this repository set up, which I'll provide links as well. But it's kind of meant to be a little bit of a workshop deal. So, all right. So, yeah, this is kind of I have a workshop set up somewhat. And I guess, did I close my other tab? Let's see, there it is. See, I'm such a professional. All right, so this is it. It's on my Java Ducky GitHub org user demo XK6 disruptor. So you can actually follow along with this. Now, some of these steps I did already perform at, at the previously mentioned Starbucks and then here finished up. So I'm not going to actually go through all these full steps, but what they will go through and do is it'll go through the installation of XK6, which is our binary that we use to actually create a custom K6 binary that includes your extensions and all that good stuff. And then this next step here will actually do the build. So that'll recompile K6 with this disruptor functionality. And then, with the disruptor, we'll be able to do things like inject latencies, inject failures, where we can say like, you'll see in the scripts that you can say, make 50% of the calls fail, return a 503 or, 500, whatever you want to do. Let's see, and then just to verify that you'll get something like that for your output, all that good stuff, yada yada. If you've seen any of my talks previously, you'll know that I love K3D. I think that's the coolest thing ever. So I actually these instructions here will create a it's K3S, K3S, but 3-node cluster inside of Docker. So just that little command there will actually stand up a real cluster with K3S on your Docker setup. So anyway, again, and then K9S I highly recommend using. Okay, and then I do give also the installation instructions using Helm to actually set up this demonstration. So all this has been performed already. Okay. So what I'm going to go ahead and do is I'm going to switch over here, and then this is in K9S. Let's see, let me go ahead. Hopefully for those online, that's large enough font. And it's definitely large enough in the room here. But yeah, so this is pretty crazy, right? I mean, all these microservices in here, just one of each. We don't need to worry about high availability just yet. But yeah, so it's a pretty comprehensive demonstration. So definitely suggest really reusing it for many, many things. And then let me do one thing here too. Let me see the URL here. Yeah, localhost 8080. Okay. Okay. Yeah. So it is running, but I forgot what you have to do is you have to. There's no ingress set up or anything, so it just had to do the forwarding for the proxy. So that one there. So let me go to services, front end proxy. There it is. Okay. All right. Let me do the port forward. Okay. 8080 on local. All right. So now if the demo gods are happy with me, this will bring up that. There we go. The demo. All right. So yeah. So this is a fun little thing here. And then, like I said, you can go through, do things, add to cart, all that good stuff. Go shopping, and then you don't have to pay for anything. It's all free. No. All right. Let me hide this thing. All right. So that is the demo. And that's running inside, like I said, just repeat that is in K3D. So just Docker is all you need for that. I like the demo or the using K9S just to see what's going on behind the scenes there. All right. And then now let me pop back to my instructions here. All right. So, yeah. Let me see. Kind of a brain fart, as they say. Okay, so here we go. Here's the demo dashboard. Okay, so the OpenTelemetry demo actually has some load generators in there they're written in Locust. It's not the cool K6 yet, but someday maybe I'll get there to writing that. But anyway, but it does sit there and it will generate activity. So you see, just like there's a live site running in production. So here, if we look at this, here's the recommendations. So this is the service. These are the rate of the activity going to that particular service. So we're gonna now select recommendation service, and we'll just focus on that particular one. And let me go ahead and let me change this to the last 30 minutes. Okay, let me set this to automatically refresh. We'll do every 5 seconds. Okay, so we're going to start seeing some activity on this one here in a moment. We'll see the differences as we inject our chaos. So let me go ahead and do that. Okay. All right. So if we look here, I know one of these is okay, yeah. So the error rates, it has 0 because everything is running hunky-dory right now, okay? So we're going to go ahead and come back to my cheat sheet for the first scenario, and then we're going to actually run this K6 test script, okay, with our custom binary. So let me go ahead and go to VS Code, okay, and then, all right, here's that. Here's this first one. So this is just a standard script for K6, okay? And then this is actually just going to create just some activity. It's not even going to inject an error right now. This is just a regular load test, if you will. So let's go ahead and run this guy. Let's see. Okay, we got that. So I can just paste that. All right, so this is running. We have it for, 30 seconds. So as we are running that, we can come back here. And then now we're seeing this activity coming in here. Here's the request rate is going up as K6 is sitting there doing kind of a performance test. So now it's looks like it's finished probably because that's dropping down now. Okay, so here, yeah, so it completed. So in that 30 seconds, we just triggered 13,887 requests. So that's the fun part about K6, right? You can do these high volume things. And what we did was we simulated 20 users making all that activity. So just in the 30 seconds there. So that was all, no problems. Everything went through successfully, right? There was still no error rate. So we're all perfectly good. So now what we'll do is we're going to inject a disruption. So this is now using still using our custom binary because we compiled in that module, but now we're actually going to use the module. So with K6, what you do here is you do the import, and this is just standard JavaScript stuff. But we're including that, and then we're going to use the service disruptor class. So here now we're going to do the setup for this so that now we're going to create our load, which constant VUs. That just means that we're going to simulate a constant number of virtual users. So again, that's the same as what we had before, with 20 users for a duration of 30 seconds. Okay, so that's our load that we're going to inject. And then now we're going to inject the errors. Okay, so we're going to, this is kind of a weird thing though, honestly, where it says the executor there, the shared iterations. There's some quirkiness with how the disruptor configuration comes in there just by virtue of how things have to be done right now. This is kind of an early on project right now. So it's, some of the things are not the easiest to use yet. But what it's going to do is it's going to create one iteration that's going to create our scenario, okay, and simulated by one single user. And And this is one of those things where it's like these, you just need to stick with that. And in this case, it's going to execute this inject false JavaScript function, okay? And it's going to start it right off the bat. So if we look here at the inject false, okay, this is what we're going to do is we're going to say, we're going to change it so that our average delay is going to be 1.5 seconds on each of those requests. Okay, and then we're going to look for an error rate of 80%. And then those errors are just going to return a 500 status code. And then, so what we're doing is the service disruptor is that we're going to actually apply it to a service resource in Kubernetes. So in this case, we're going to use our recommendation service that's in the OpenTelemetry demo namespace. And then we're just, here's just to go ahead and put it in there. And then we're going to execute this fault. And then we're going to have that run for 1 minute. So we're going to create this chaos for just 1 minute. So otherwise, everything else is the same as that previous script, which just created the activity. Okay, now the threshold is just another K6 thing where we're going to confirm, we're going to say if our test doesn't do more than 10 requests per second, we're going to just fail the test. So we'll return a non-zero return code. And, so if you had CI/CD going, it would fail because it's like, that's not a good enough test, that type of a thing. But you can also do if your failures reach 20% or something, stop your CI/CD pipeline. But anyway, so this is the script that we're going to go ahead and run now. And let's see, let me go ahead and do that. All right, and no, it's more than just the number. Okay. All right, so again, we're going to just tell K6, our modified one, to run this script that we just looked at. Let me clear that. Okay, and then now you'll see that there's kind of 2 threads of activity going here. So we have the load that's being generated in the background, and then we have the injector script that's going to run for the 1 minute. And so now if we go ahead and look over here at our system here, we should start seeing another spike in activity. It should reflect our delays, and then it should reflect the errors. Uh-oh. Hopefully I'm not lying. And I did rebuild the code, but I don't think they've made any significant changes where it's like, okay, that the latest is broken.
It looks like the injector just fired or reported.
Yeah, it was just finished for that 1 minute duration. Yeah. So there, we'll see. Hopefully it's just maybe lag. But yeah, so we did get, so now previously when we had everything running, no service interruptions or injected service disruptions, that's it. We had, what was that? Like 12,000 requests, I think. Now our HTTP requests were 2,500, just over, because of that delay, that latency that we had injected there. And then let's see, where did we get? I thought I saw some the exceptions. Yeah, expected responses. Yeah, so this is that was our failures. Wait. Let me swap back over here. All right, this is not. This should have. This is the bad part, is that and also too, OpenTelemetry demo is something that like New Relic, Honeycomb, Grafana, everybody kind of contributes to, because it's totally open. And then I did a very fresh install of the demo, so I'm hoping that the Grafana that the dashboard isn't actually broken. What it does is it'll actually inject an agent. It'll have an agent temporarily in the pod, so it'll add just another container, and then that'll actually do your delay and intercept all the activity. And then after that duration is complete, then it'll remove that container from the pod. Yeah, so that's what's actually going on there. So unfortunately, I'm not sure what the heck is going on here, because normally in the past, like I said, this block here for the error rate would actually show activity for those failures. So yeah, I don't want to go through and try to debug a Grafana dashboard. It's not actually my my jam. So yeah. Yes. Yeah, so with the OpenTelemetry, they have it fully instrumented. So each of the applications that are written in all the different languages are using the OpenTelemetry client for each one. So they're emitting all the metrics or in all the tracing. No, I mean, well, so these custom dashboards are just included in the Helm chart. So we're actually running Grafana and Prometheus and everything locally in that Docker container.
I guess I'm just kind of wondering, because I imagine that these dashboards show the traces emitted by the application.
Mm-hmm.
But then when you inject the services disruptor, are the requests actually reaching the application?
Oh, that's a good question. I think so. The ones that are like the errors, I think, are just being returned by that agent, that sidecar, I should say, not agent. So they're probably, yeah, not even hitting the application. So yeah, true. Yeah, because I don't think it's intercepting it on the way out. You know, the response coming back out. I mean, that would kind of be kind of weird, because you'd have a success, but then it's just returning a failure code. Yeah, yeah. So yeah, so that's kind of weird. But I know, like I said in the past, it actually did show this. So I'm not sure what's going on there. Again, like I said, and then let me see what the Jaeger link is. So like this demo actually even includes Jaeger. So if we want to see some of the traces, so let's take a look at some of those traces from recommendation service that includes that. There it goes. All right. So let's see if we can find something that's in that. And I don't use Jaeger normally here either, but let's see. Yeah, it's not. I wonder if, because yeah, there's no traces in here either, because it's not seeing any of the services or anything, but Jaeger's obviously up and running, but yeah. Well, here it's showing that seeing these services to be able to have them listed there. All right. So yeah, normally, oh, there it goes. All right, weird. I'm going to blame it on my machine just having too many things going on. But yeah, so we can take a look here. So some of these calls, yeah, it took 1 minute and 42 seconds for a front end call that went through the recommendation service. Yeah, it's not showing the oh. All right. When did I unplug my power? All right. But yeah. So that was only 757 microseconds. Anyway, but yeah, I don't know. But again, something's going on there. But we were able to confirm, at least based on these numbers here, that significantly less throughput made it through successfully because of the injected disruptions. Yeah, so I don't know what's going on with the dashboard thing. But like I said, there's lots of hands in that, but they do have test code around it pretty good. But used to work, but anyway. But yeah, so let's go ahead and go back. But that's really primarily it. But you can do things at the service level. So you hit all the pods essentially, or it'll affect all the pods, or you can do it at a specific pod level with the service disruptor. So there's a pod disruptor as well. Let's see. But yeah, so that was kind of anticlimactic with that the dashboard thing. Yeah, it's really cool when it shows the errors. Did I switch services or no? Okay. All right. Well, anyway. I'm sorry? Yes. Yes, K6 can emit metrics itself. It can, so you can have the Prometheus plugin where it'll send the metrics off to Prometheus, and then that way then you can see that data in there for each of the tests as well. And one of the cool things too is that you can have it actually emit trace IDs. So that way then if you're doing some tracing, you can see it, where the actual error was triggered by one of the load tests. So, but yeah, so let me go ahead and switch back here. Let me find my, there we go. Okay. And let's see, but yeah, so that was all on the demo, which, like I said, again, it might be anticlimactic there. Apologies. And go ahead and set that. All right, let me double check to make sure the stream. Yeah, that's really bumming me out though, because those errors used to show up there. Okay, and it looks like we're presenting this again. So, good deal. All right. But yeah, so now, so again, by applying the chaos principles into your tests, we can reuse those load tests. So those tests could be included in our CI/CD pipeline and reused, and just make sure that we continuously improve those numbers. That we can sit there and then inject the latency and error rates, even though they're not displaying on our Grafana dashboard for the demo, but they really happened. And then we can again affect a single target service, or let's see, or pods even. It's not listed on there. Again, tests are repeatable and predictable. The injection of the faults are coordinated by the test code, and then it should not include or add any operational complexity. So it's really just doing your normal stuff there. And so where we go from here, you should cover all these bubbles in your testing strategies. So the addition of the chaos testing there is mainly the issue there. Continuously improve. Make sure that you have some sort of observability platform, whether that's Grafana or something else like a Datadog or whatever, make sure that you have that you're using that. You can use the K6 or Locust or Gatling or any of those to generate activity. But, K6 you'll want to use for the disruptor to inject those. And yeah, so we just, this quote here kind of always cracks me up, though. It's, the ability to operate reliably should not be a privilege of the technology elite. But yeah, no, we just want to make sure that chaos engineering principles are democratized, that we can actually use them in the development process early and often to complement our existing test practices. And then, and I guess, same thing again, a little redundant, but yeah, so we want to help everybody make reliable systems, and that's all I got. Thank you, everyone. All right. Any questions? Any other questions, I guess? Not why errors weren't showing up on the dashboard, because I'll have to take a look at that. I don't know. That's what happens when you use the latest from a branch always, right? Or, well, from the main branch. Things happen.
I don't know if I have any questions just yet, but I know my reading list just tripled.
Awesome. Well, that's good. Yeah. At least you got some additional reading to do. So yeah, it's all good stuff though. It's really fun. I will give the one caveat though with the XK6 disruptor. We only had like 2 folks kind of working on it, and then right now it's even dropped in priority, unfortunately. So they're not getting to work on it as much as they'd like to. So please, anyone that is looking for a project to work on, please definitely take a look at it. It is pretty cool stuff. It is early on. There'll be some bugs, but and then we're looking to add to the different types of disruptors that we can inject. All right, then. Well, cool. Well, again, thank you. And then let me go ahead and I'm going to cut off the stream now. So all you kids watching at home, thanks. It's bedtime.